Now it's back. Hmm. All right. Well, maybe we can. Yeah, if somebody has the secretariat there, then we can get going. All right. So we're gonna get
Um,
started.
so to interrupt, I can take notes.
Oh, great. Thank you. All right. So we'll get started then. This is the Privacy Pass meeting here at IETF 122 here in Bangkok, and we also have Ben Schwartz, who's not here on site but is on the call. One thing I will ask folks to do is to switch off your camera and audio if you're remote until you're going to be talking. Let's see, I think I can do this. All right, so you should all be familiar with the Note Well and all the various procedures around IPR, the working group processes, anti-harassment, code of conduct, etc. If you're not familiar with it, please take a look at these links. And in particular, we want everybody to be civil and respectful of one another during the discussions. Keep discussions focused on the technical issues. And if you have any concerns, you can raise, there's various ways you can raise those concerns, including talking to the ombuds persons. All right, just if you're here on site, please log into the on-site meeting tool. That's how we will conduct the mic queue. And again, yes, please have your devices muted and video off until you are talking. Here we go. So, I thought okay. So with a batch token, just as an update, I thought we had the agenda. Let me see if the agenda. Okay, so the agenda we'll go through just a status update, which we gave you a preview. Yeah. Do you have a agenda, Bash?
Yeah, please. I'd like to see if we can swap the order and do the anonymous credential stuff first, and then like the main stuff on the back half of that, if that's okay. I talked with the various proponents, and they're mostly okay with that.
To switch it to the.
So basically, there's two halves of this meeting. Like there's like the regular privacy pass stuff, and then there's anonymous credentials. I'm just suggesting flip that.
Okay. The reason why we had it this way is to kind of keep the working group documents up front. But I think we can switch it. Is there any objection to switching?
Yeah. I'll absolutely do. Happy to go first.
All right. I think I'll give this brief updates, and then we can put you in. Ben, do you have any concerns? All right. Hey, Ben. Can't hear you if you are talking.
Yeah, we can do that. We'll put a timer on that to make sure that we reserve most of the meeting for Privacy Pass active draft business.
Cool. All right. So for batch token issuance protocol, we're getting working through getting the revised draft based on the working group last call comments, so that then we can start moving that towards the IESG. We have an adoption call currently in progress for Privacy Pass token expiration extension. So please comment on the list on that. If you support the adoption, it's really helpful for us to get feedback on that. Or if you don't, obviously, let us know. And then we are planning to do working group last call for the issuance protocols with public metadata and private token HTTP authentication scheme extensions. Okay, so then let's We've bashed the agenda, and let's go start in then with who do we want to go first? Chris? Did you try to share?
I'm trying to request right now.
Yeah. Stop. Okay. There you are. Did that. I have to stop sharing. Where is stop share here? Do you see what am I missing? Why can I not? Does anybody know how to stop sharing?
Forgot how to. What's the chair action? Forgot how to use these things.
Stop sharing slides.
Yeah. So go over here. Click on, yep. Lift the check mark.
Yeah, and then it gives me a thing saying all the
Yes,
requests.
you need to stop sharing.
And where do I do that?
You do that right there.
Oh, thank you.
And then
Yeah, perfect. Thank you. Thanks. All right, sorry for that brief technical difficulty. Did you accept the slides? I did. Try again. If not, I can give you control with this thing. If you want to do that.
I propose slides, but I don't see them on there.
Yeah.
Hey Ben, I proposed slides, but I don't know if you had a chance to approve them. They're not. Yeah. Wait.
Um, yeah.
I'm gonna sit here. If that's okay.
Your slides should be there.
I didn't get email them yet.
Yes. So,
Yeah. Steven's ultimately.
are those the right ones though? All right.
So we're presenting on some anonymous credential work that might be of interest to PrivacyPass, what the scope of it is, and whether we want to explore that work here. There's been a few people who have worked on these slides, though we've had other people involved. Michelle will be presenting some of the underlying crypto stuff later in this slide deck. Okay, so the format of this is we're going to talk about some of the use cases, mostly the existing ones and some of the new ones that have been coming up in recent months. Talk about various extensions to anonymous credentials, and then what possible next steps are, whether it's in PrivacyPass or elsewhere. So as a quick reminder, terms, we have client and prover. This is an entity proving something about themselves, which receives a credential from an issuer and a tester, which is the party that signs these credentials. Then there's a verifier who actually sees the credential and verifies its validity. There's both public verification, which the verifier and the issuer are separate parties. One might have a public key, the other one will have the private key. The version we more have in PrivacyPass is private verification, where the issuer and verifier tends to be the same party. Other differences with anonymous credentials, PrivacyPass and a lot of the anonymous credentials here have mostly been single show, where you use a credential once, that's it. You have to get a bunch of different credentials if you want to reuse it multiple times. A lot of the more recent work has been around multi-show, which I think is currently isn't in any of the PrivacyPass drafts, but I think there's been a lot of interest here. This means you don't have to do a ton of issuances while using the credentials in a ton of places. So we've seen three main directions where anonymous credentials are useful. There is authentication, where you, third order, where you want to have a privacy-preserving way of showing that you have some value. You don't care who you are. This is usually rate limited to some extent, and you don't want to be able to like replay it a ton of times. There is the rate limiting case where you want access to resources to be limited. You don't want to be able to load every single blog on every single post in a blog 1,000 times and scrape it or things like that. The other use case that we've seen in W3C is around anti-fraud, being able to collect signals in a privacy-preserving way and then end up with a result out of this that is used for both access and for figuring out what the value of that interaction is. So there's been three main existing use cases. There's private access tokens by Apple, which is the device or a trusted party generates some signal about the user that's used in place of CAPTCHAs and other sorts of rate limiting schemes. There's private state tokens where websites are the ones issuing tokens and then other websites are the ones redeeming the tokens. And then for some of the proxy authentication schemes, there's been the use of tokens to authenticate to the various proxies involved in the chain. And these are all very closely related to PrivacyPass or PrivacyPass derivatives and have been mostly the scope of the work in this working group. So there's been a number of new use cases. First is rate limiting. The rate limiting scheme that we currently have in PrivacyPass is a bit messy / broken. Chris will be talking more about this in the next presentation. And this moves towards more multi-show schemes, so you don't quite have to do quite as much work. The second use case is a common problem that's come up in PrivacyPass is the sort of centralization problem where you end up having only a single issuer or a single attester involved in the system, and you are concerned that the ecosystem would be limited like that. There's been some requests by folks of having sorts of groups of issuers or groups of attesters and these sorts of more anonymous group schemes to allow for or to reduce the centralization problem. The third use case that has come up is this private proofs, where there's some amount of metadata, and Scott will be talking about metadata in PrivacyPass later. But metadata by itself can have a lot of entropy. It could leak a lot of signal. There's cases where you only care about certain facets about that metadata. For example, if you have an age, you only want to know whether this is more than a month ago. And be able to run calculations on that metadata would be valuable without fully leaking the full entropy of whatever metadata is stored in the token. There's actually a new API explainer that came out yesterday that hopefully someone will share in the Zulip that talks about this use case. Hopefully in the future we can go more into it. The key part here is you don't want to reveal anything about the metadata value, and you only get a single bit out of this. And hopefully that mitigates some of the public metadata concerns we've had in the past. There have been a number of future use cases. These aren't very well thought out. There is pseudonymous identities. Some of the BBS work in CFRG has gone on these lines. There's age verification use cases and having time scoped in addition to rate limited credentials. These probably need more working out to see whether they're relevant or interesting in the space. So Michelle will talk about some of the actual extensions in this space, but if people have questions about the previous use cases first.
Tommy Polly Apple, just a clarification question for, you mentioned it in the rate limiting use case, which I care about. I think these are nice properties for that. You're talking about the multi-show aspect of that. Can you clarify what you're meaning here by multi-show?
So all the current constructions we have in PrivacyPass, once you use up a token, if you allow reuse the same token, like you effectively can't, and the framework and architecture here doesn't really allow that. I think we'd need to expand some architecture, and like the ARC work would allow for this sort of multi-show of tokens, right?
Right. So Right, like in normal, like an RSA blind signature, right? Like you only have one thing, and so if you don't want to be correlated, you can't replay it. In stuff like ARC or BBS, from what I understand, right? Like we have the credential that we get at the time of issuance, and then we can generate different presentations. So like any one token, like I guess when we're talking about the privacy pass context, any one piece of information isn't being shown multiple times. It's just like the client is able to derive
They can generate multiple proofs.
more, right?
Yeah.
So I guess this would just be a question of, because I think this is good for privacy pass and we should include it in privacy pass, but like when we think about the terminology, like these tokens feel more like the presentations than they do the credentials, and it's almost like some of these things are ways to extend the issuance or generation of tokens to be able to do multiple things, as opposed to I think it has very different properties from just like, now I'm going to just replay and re-identify myself over time.
Yeah, I think we'll go into a little bit of like how you would actually do this and how you separate proofs from the credential itself, and like how we have to rethink of what privacy pass is providing in that case, since the client's regenerating.
And if I can complete maybe for Tommy the part between show once and show many, which are, I see them as different type of credentials. Of course, one can imagine an application that gives like 1,000 like privacy pass tokens that can be spent only once, and the user will have to spend and burn one of them at a time in place of these credentials that are multi-show that can derive one-time tokens. However, the problem here is that this puts the application layer the burden of tuning the number of credentials to be issued, how to refresh the tokens every time, and schemes that put this burden on the cryptographic part, on the primitive part, are generally much more efficient because they take into account this scenario. So maybe can I have control over the
I think Jonathan
slides?
has
Maybe.
a question first.
Oh,
sorry. Jonathan Oyland, Cloudflare. Would it be equally correct, let's say, to call it delegated self-issuance? Because it's not really multi-show, because you never show the same thing twice. It's just delegated self-issuance.
Yeah. I think all the schemes are basically that. Kel, do you want to take over?
Oh, awesome, thank you. Yeah, so this was meant to be a bit of an overview of the theory. My name is Michele, I'm a researcher, and the best I think I can do for the group here is maybe to share an overview of the way in which I see the cryptographic literature around credentials so far, and the way in which I think we can pile up layers so that we allow for things to be future-proof and try to counter maybe some misconceptions about what is the cost and how these primitives can be implemented. In its sort of widest meaning, when we talk about anonymous credentials, we're talking about pretty much signatures, but instead of just revealing them to the verifier, to the server, we give a proof that these signatures are valid and that they satisfy a particular predicate. So whereas before, or let's say with normal signatures, we give a message and a signature to the server, and then they check some properties on them. Now we're asking to replace this with a proof that the same statement is true. Even privacy pass, in the way that it is right now, sort of fits this scenario, except that we're just revealing the token and the signature associated to it. And so in order to build anonymous credentials, you need two things. You need a signature and you need a proof system. And this matches not only what's happening inside Privacy Pass, but also some drafts that are coming and that are not necessarily tied to Privacy Pass, and even some proposal around outside of Privacy Pass, even in the digital identity sphere. Now, if the proof system and the signature scheme are compatible in some way, in terms of cryptography, we can push things really far and make protocols that are really efficient, because the arithmetic and the language that we use to talk about proofs are the same. Now, before diving in the theory, in terms of like what is needed, in order to build credentials, we could base these all only on one-way functions. One-way functions are sufficient for zero knowledge, which is sufficient for signatures. And so even if the whole public key infrastructure were to collapse, credentials will stay there. And to me, this is a really surprising sort of aspect in theoretical cryptography, that this advanced cryptography needs only to rely on symmetric cryptography. But now this is only the theory, and in practice, oftentimes for signatures, we use public keys. Let me go through some of these examples. So PrivacyPass for me is a type of credential that relies on a signature. And what we want actually is not only a signature, but a blind signature. And there are either blind signatures like RSA or blind MACs, the way that I would call them, like the VOPRF RSC. And here the cryptographic proof is literally just send out the witness, and which is why they can only be spent once, because we are literally giving out the signature itself. We seem to be now moving towards specifying other types of signatures that are what I call algebraic, the part about being compatible with the cryptographic proof system. And these are CMZ and BBS that are respectively in the ARC draft and in the BBS blind signature draft. Both of them rely on the same type of zero knowledge proof, and there is alignment here on making it so that this layer is developed in common. But there are other types of specification, like the SPICE work, which relies just on a signature scheme and has no cryptographic proof, and maybe in this way has the least guarantees in terms of privacy. And finally, there is also a recent draft from Google, libzk, that is based on a generic signature scheme, for instance, a CDSA, and uses a generic SNARK in terms of cryptographic proof. And now there is no reason why we shouldn't also be able to mix these layers up. For instance, mixing ARC with another type of proof system like Ligero, or another type of SNARK that will allow, for instance, proving more complex PRFs in the future. This is only like for the technical people, this last sentence. There are also other type of credentials that happen outside maybe of the sort of normal flow of standardization and of literature, like semaphore, which has been widely used in the blockchain community, that relies more on accumulators plus cryptographic proofs. All of this to say, if there are some exceptions to the rule, but they do not necessarily satisfy the scenario that we have in mind here within PrivacyPass, where there is an issuer and a verifier. Once you have a core credential, you have the simplest predicate that are possible to do are selective disclosure. And this is like really the basic feature that you would expect from a credential. But we can do so much more. And I think a nice mental exercise here is to imagine how this feature, which are some of them at least well established by now, can help reshape the way that we interact on the web. And before I dive into the examples, this extension will affect the security. So if a core credential system is perfectly hiding, but the pseudonym extension is only computationally hiding, then obviously the credential system at the end with the extension will be only computationally hiding. Some of them that I think are particularly useful and that have an intersection with PrivacyPass are expiration, that is about saying that this user is new enough. And this boils down to making a zero knowledge proof that a certain attribute is in a certain range. Embedding private or public metadata about the user. This is actually the way in which I started contributing to the PrivacyPass group. And pseudonym, which is about associating the user to an ephemeral identity that is given per context.
They're cutting out a little bit.
Ah, shit. I can try to go slower, but can you hear me better now?
No, maybe try moving closer to the mic.
Just a sec. Let me go to network. I'll be back in a sec.
We're not hearing it. No, we're not hearing you at all now.
I think he's coming back.
How about now?
Sounds good.
Awesome, thank you. So I was saying pseudonym would be about accessing, determining a unique identity that is previously authenticated per URL. Rate limiting, I see it as a generalization of that, where you're able to create an ephemeral identity, a certain number of ephemeral identity within a given resource. And all of these, I think, are very well stable. I tried also to study them myself in the paper and prove as much as I could about them. There are some others that I think might require a little bit extra work, but that we're almost there, and they are very much studied in the literature, which is issuer hiding, meaning I want to hide whether I got this credential from issuer A or issuer B. And finally, revocation, about removing the credential of a user that has misbehaved just on the basis of the credential that was presented at an earlier time. And so I think all these features can, like if I have to push it all the way, I see these features really as a way of removing or rethinking cookies and logins on websites in the way they would allow us to decouple identification of the user, where we get the information about them, from authentication of the user when the user makes operation on the system. Now, the literature on credential can be kind of frightening. It's very wide, but there are two axes over which I like to see things. First one is whether they are keyed verification or public verification, meaning is the issuer is the same as the verifier. And the second axis is show once and show many, meaning is the credential going to be presented only once, or is it going to be presented many times? And as I said earlier, obviously, while between keyed verification and public verification, we do have some barriers. We, at least for the primitives that we're considering in PRIVACYPASS, we kind of expect that to go from keyed verification to public verification, you need pairings. To go from show once to show many, well, in theory, you could just, just give a bunch of tokens every time, but this is not exactly the most efficient way of doing things. And there are systems that are conceived in order to allow for that. And so if I have to think of like what goes in this quadrant, keyed verification show once was the initial PRIVACYPASS in the whole anonymous token literature. Show once with public verification or blind signatures. And the fact that they are show once allows us essentially to rely on blind signatures. And the proof is really just send out the message. When it comes instead to show many, keyed verification, we have CMZ, which is the sort of the core scheme used, for instance, in the ARC proposal right now, and it's a sort of alter ego that is publicly. I'm sorry. There is still a problem with the audio. I will keep on talking, but otherwise, I guess I don't have another way of connecting here. So there is the and sort of the publicly verifiable version of CMZ is Poincheval-Sanders, and the same thing happens with BBS and BBS signatures, which are now specified, and BBDT, which would be the keyed verification version of them. They are extremely intertwined in the sense that the cryptographic and the cryptography and the algebra is very similar. The proofs of security are slightly different. One parenthesis in terms of security is that my impression is that BBS relies on Q-type assumptions. So it is exposed to the same problem of PRIVACYPASS of the static Diffie-Hellman sort of problem, where you're relying on the best attack that is known is essentially Chell's attack or Brown-Gallant. Whereas in CMZ, I think we can build a proof that relies only on another assumption called 3 discrete log. So the degree does not go up to Q, meaning while in PRIVACYPASS, the number of credentials issued seems to be affecting the security. In CMZ, this is not the case. Okay, and the way in which I see these credentials being done, or the way that we think about them in the theory, I think should also reflect the way in which we specify them. And we do have specified some algebra component, the proof system layer, and we can sort of swap the proof system depending on how things evolve and depending on the credential. And even the extension layer can rely on different credentials. For instance, pseudonyms, there is no particular reason why they have to be tied to BBS instead of another specific or of another credential system. And so I guess my point here is that there are like a bunch of layers that we can think about them differently, and we can think about them differently. And
I think Tommy has a question.
Yeah.
Tommy Polly Apple. Yeah, thank you. Just going back, actually, if you go back to the slide before where you're talking about, the taxonomy here. So with the current tokens, we've defined a publicly verifiable type and a privately verifiable type. And I love adding this other dimension. And we have and we see options of how to instantiate these one credential, many presentation tokens that are publicly verifiable or privately verifiable. And previously, we chose to kind of define both because maybe in different use cases, we'll want to have both. I just want to hear from your perspective or anyone else's perspective. Do we see value in both flavors existing? Are the trade-offs different than they were in the other case, or should we define here are the primitives, here are ways to instantiate them that are publicly verifiable, privately verifiable, and let different use cases decide? Are there inherent trade-offs between these two?
Yeah, I don't know exactly operative what is the best way, and I kind of trust some of the people in this meeting to make better choices than me here. But as far as the trade-offs are concerned, as I mentioned, the only one that comes to mind is that key verification does not need to rely on pairings, where public verification does, for the primitives that we are considering. If we were to consider schemes that are based on lattices like LWE or simply based on hashes, this difference does not exist. Nonetheless, the schemes that we're considering are mostly based on discrete logarithm assumptions, so this difference does exist.
I guess in terms of like which of these we should be focusing on privacy pass, I think we've had a problem in the past that we like define a bunch of variants and a bunch of like attester issuer combinations that like never actually get used, and like this results in things that don't work. So we're like we should figure out what use cases we want to focus on, if any of the new ones, and build things for that rather than build generically and then end up with things that no one ever uses and are broken.
Right. And I do believe there is an API that we can just make so that it's future-proof without necessarily having to specify other extensions that are not used.
Sure. I mean, just to clarify for what's broken, like as far as I know, like, we have deployments that are out there that use both the privately verifiable and publicly verifiable types. We have deployments that use split attesters and issuers and cases that use them combined.
I guess the main thing here I'm thinking about is the rate limiting stuff that currently not broken, but has a lot of rough edges.
It's complicated, right? Which I want this to replace.
Yep.
That, and that's great. But like, I mean, since like there could be different properties between the two sides, I just want to have it in mind that as we're talking about this, do we want to design an architecture that lets us have both cryptographic instantiations without having to do a lot of work to swap between them if there are different use cases that just want them, or do we want to just say no, there is one algorithm here and that is the one we recommend, and if you want the other flavor of it, too bad?
I think maybe the easiest here is that if you define the API correctly of the credential system, the credential system will take as input the predicate that you need to prove upon presentation. And all these extensions, expiry, pseudonym, metadata, rate limiting, they're just predicates that you need to prove. They are nothing else but predicates that then you plug into the credential system for doing the whole credential show part. So I do not see it as different properties that will affect. Yeah, I cannot. I don't have in mind any different property.
Right. And it seems like those different use cases, couldn't. I like how you're phrasing it, but like they could probably work with both flavors of verifiability. And in practicality, when I've seen the difference between the verifiability, it's more about the deployment reality of how tightly coupled are the verifiers and the issuers of tokens, because like when they're the same entity, great, it's fine for it to be privately verifiable. Sometimes it's very inconvenient to have that round trip on the server, and it's less about the use case, it's more just about the deployment reality of which servers are needing to verify and what keys do they have the private key or not. Yeah.
Sam's on the queue.
Yeah, I just wanted to mention some of the trade-offs that I've seen. Specifically for performance, for public verifiability, you give up like anywhere between 2 to 4x performance when I benchmark. For rate limiting, we have the same type of difficulties with public verifiability, where you need to somehow either shard the rate limiting or have rate limiting which is global and manage that somehow. And then I think for a lot of the use cases I see for pseudonyms, you really want that to be public verifiability. You pretty much always do. There's some drafts working through the BBS world for per verifier re-identifiability, which I think fit this really well. And so I think if this group were to focus on the key verification stuff, and the people working on the BBS work could modify the per verifier linkability stuff to support rate limiting, I think that you could sort of break up the work that way practically, and I think that yields pretty useful stuff. There's some changes that need to be made to that specification in BBS world, but I think it's a pretty simple change, and I've been talking to them about that.
Yeah, and to maybe like validate more what Sam just said, when you go to pairing curves, you're augmenting the elliptic curve modulus, so there would be about 1.5 times the field that you were using. You're going from 256 to 400 bits, and so that's 1.5 times larger. That's a roughly times 2 cost that you're going to pay.
Yeah, just to give one more like concrete thing about the difference between the schemes, you can really write them down in such a way that public verifiability and private verifiability actually spell out pretty much the same. You just sort of swap out some equality checks for some pairing equality checks, and I think that's quite nice as well. Like you don't have to have extremely different or divergent algorithms involved.
Exactly. And what I'm trying to say here is that I'm not necessarily advocating for creating a bunch of interfaces and layers, but at least there are these other specifications that are around, and we should look at how they're doing the API, and they should look at ours, and we should be talking on how to do things. I'm going faster because I don't think there is much time
we might
left.
want to just skip to the next steps one and we'll
Exactly.
discuss
So I see many layers, and one of the things that I think are a big misconception here is that like one example is that using pairing, well, I can still do like Sigma protocols and BBS and use pseudonyms. But another example, for instance, would be what the ARC people are doing that are relying on Sigma protocols, but just on groups and then using CMZ to build rate limiting. But I just wanted to sort of emphasize the fact that we know very well how to swap the zero knowledge layers and how to make them communicate. And again, there is no way why a single specification should, for instance, specify the zero knowledge proof layer and compile it all the way down to the statement that they're proving. Here we have Vasilis that is sort of taking care of BBS, Kathy is taking care of CMZ, Vasil is doing NIM extension, Kathy is doing rate limiting. And so there are all these little modules that what I want to highlight here is that all these things are sort of interoperable. And as we move forward, it will be beneficial for every specification if some of these layers are at least communicating to each other. And like, this does not have to be hard. A subset of them is already on their way in terms of draft, is already on their ways. It's just about making the right choices of interfaces and make the right layers. My point. Mhm.
We need to kind of get moving. So if you have a summary
This is the
slide.
last slide. This
Can
is
we
last
skip
slide.
to the next one to do the next steps? We could probably go over this on the list. Yeah, so I think the open questions for the working group is like, are these new use cases, additional use cases beyond what PrivacyPass has currently been focusing on, worth exploring in this community group, or sorry, working group, or somewhere else? Like, there's a lot of interest in the rate limiting ones, so with ARC stuff. These other components, I think, would be valuable. But yeah, there's a big scoping question of we don't want to pick up too many things here. But like, this does also seem the correct working group for some of these concepts. Like, there's SPICE and other related groups, but I guess a lot of the interest in anonymous credentials has been happening here. There's also a split between the cryptographing protocol work that I think Chris will talk about a little bit. And then I don't know if it's on this slide or the next one, but what are our next steps? Perhaps we can get some folks who are interested in anonymous credentials to have more of a sort of design team to have documents to propose next time if we think the working group should be discussing this. Maybe we can take some of these questions to the list. Martin?
Martin Thompson. So the most important question that I think you need to ask is whether this is the right venue to have this work done. When you started getting into this, I was thinking, oh, maybe I could squeeze this into the group, and then you had more and more and more and more use cases, and you didn't even really cover some of the deeper ones, like the pseudonymous identifiers and re-identification that way. I think this is BOF scale, not just shove it into an existing working group scale. I think there's enough here that we could occupy our time in a whole new working group, and I would love to see that working group happen. But it looks like there's still a lot of work to be done to sort of line things up so that the BOF could happen in terms of getting the pieces together. As Michelle pointed out, a lot of the work has been done, but there's a few final fit and finish pieces that are necessary to get the full picture together. Now it may be also the case that you just want to have a narrow scope to start with, and that may be the best approach. But the work then would be to work out what that narrow scope is, so that we can do that, whether that be assertion of traits or rate limiting, or, I mean, this group is very interested in rate limiting. If it was just limited to rate limiting, I would say do the work here. But I think we're talking about going somewhat beyond that scope when we start talking about these things, and that's a new working group for me.
I think figuring out like what the interest level is in this and like figuring out how we scope it, I think is the good next step.
Yeah.
Okay, please keep your comments brief so we can move.
Okay, came up to say the same thing. I think it's all about scoping, and I think that's what we should focus on in the list is like what makes sense to do now versus what we should leave for later or for a BOF possibly. And it's probably a question of what have we looked at before and what don't we like about the existing protocols that we can fix with these. Batched is a good example where like this might be more efficient for that.
Yeah, I agree with this overall setup there. I think that like this group has interest and problems in rate limiting. And I think we will see like there are ways to express BBS or ARC in terms that like work inside PrivacyPass, and that fits here. I guess the big question for me is like, do we expect that these other use cases, which we like are scratching the surface of, are they things that use BBS or CMZ that express themselves in different ways, or do we think they'll express themselves in ways that end up looking similar to PrivacyPass? And so like, do we end up with multiple working groups that use similar crypto base, or is it like a new protocol that subsumes PrivacyPass or extends PrivacyPass that is being used for all of these cases? And that's the thing that would be good to have a little bit of research into to determine what scope belongs here, or does this need a buff or whatever.
Great.
I
for the time.
think. Oh,
Yeah,
sorry.
I think we need to move to the next presentation.
All right. Hello, everyone. On the heels of that setup, I'm going to talk about a proposal for integrating anonymous rate limiting credentials, or ARC, into PrivacyPass. As the name sort of suggests, this is specifically for the rate limiting extension that anonymous credentials provide, not for other things, though it could be extended for other things depending on how this group decides it wants to go forward with the work. So for some history, to sort of explain why I'm focusing just on rate limiting, let's revisit sort of the original PrivacyPass protocol, the ones that are specified in RFC 9567. As Stephen was saying, there's these different entities that exist in the system. Client interacts with an origin to request something. If the origin doesn't like it, the origin says, hey, client, give me a token by a token challenge. If the client doesn't have a token, it goes off and runs the issuance protocol between the tester and issuer to get a token, and then retries its request with that particular token, hopefully succeeding. And the beauty of this is that the initial protocol is all built on very well understood and simple primitives. Like the token challenge is just a nonce. The token itself is just a signature over that nonce. And the issuance protocol is just blind RSA or VOPRF or whatever. Nothing complicated, nothing fancy. Things that have been in the literature and well understood for many years now. The problem with this particular protocol, though, is that it has sort of a linear cost associated with it. So every single time an origin wants to ask a client for a token, the client doesn't have one, has to go out and fetch a token. And there are optimizations you can do, like the batched issuance protocol, where you can fetch a bag of tokens at once and then replay them, cache them, and use them when requested later on. But at the end of the day, you're still taking for every single token, you're still doing exactly one sort of token request. You're effectively asking for one signature over one nonce, because you can't replay nonces over and over again, because that would like immediately violate the privacy properties that you're supposed to get from this particular protocol. So that's not great. The I guess other problematic part is that as an origin, if you wanted to control how many particular tokens come from a particular client, you really have no way of doing that other than sort of limiting how many tokens are sort of emitted into the universe. Sort of by design, you cannot like inspect how many tokens a particular client has, because the protocol doesn't reveal anything about an individual client. Every single token that comes to you as an origin is indistinguishable or unlinkable to the other tokens that you get. So you have no way of like doing fine-grained rate limiting, which is a problem in practice. All that means is that you know, the initial PrivacyPass protocol, while sort of very simple, well understood, easy to deploy and use, has these limitations that make it not so easy to scale to large deployments in practice. So the group here identified this as a problem, and we said, well, we'll go out and we'll try to take these existing primitives that are well understood and well used, and we'll twist them into a way that we can implement rate limiting using existing primitives. And we came up with this very complicated protocol for rate limiting that depends on a sort of complicated system arrangement between all the different parties in the system, the tester and the issuer and the origin all to be separate. And it's, you know, not only is it blind RSA, but it's some other stuff that's going on under the hood, still using sort of quote unquote classic cryptography. But it's way more complicated than it needs to be. And not only is it more complicated from like I guess a protocol perspective, from a deployment perspective, but also it has not the best privacy properties, like by design, because there's an entity in the system that is not the origin enforcing rate limits. There's some sort of controlled amount of leakage that takes place in the system. And we were like, okay with that, because it was the best we could do at the time. And also, this doesn't even address the sort of scalability issue, where if you want to, you know, not issue a or not ask the client for, or not force the client to go through the issuance protocol every time you ask it to produce a token, There's nothing about that, which is not great. So it only addresses like part of the problem with the initial base privacy pass protocol. Okay, and so that all motivated ARC, or this anonymous rate limited credentials proposal. We sort of took a step back and said, rather than trying to like twist and contort ourselves using these like existing primitives and coming up with a complicated system, why don't we just use like what's well established in the literature, these anonymous credentials, to do what we want to do in a more elegant and clean way. So ARC was specifically designed to basically replace this protocol that the working group adopted that has rate limiting as sort of the first class feature that the thing purports to provide, but also deals with the scalability issue. And that's it. That's basically all it does. It's fairly simple, and the interaction between the different parties in the flow of the protocol is also very similar. So a client would ask an origin for a request. Origin would come back with a token challenge, just as it normally would. If the client does not yet have a credential, it would go off and run the issuance protocol to produce a credential. And then from that credential, it could derive additional tokens. And the beauty of the credential in this particular case is if the client has a credential and it later gets challenged with another token, it doesn't need to go off and run the issuance protocol again. It could just simply derive a fresh token from that credential up to the rate limit. So the syntax for ARC is fairly simple as well. During the issuance protocol, the client just inputs what we call a request context, or some arbitrary thing that's specific to the application. Server inputs its private key, and out pops a credential on the client side. The server gets nothing from this interaction, sort of by design. Doesn't learn anything about the client other than like the fact that it issued it a particular credential. Over on presentation, once the client gets a credential, it inputs another what we call presentation context, which again is application specific, as well as a presentation limit, which is effectively the rate limit. Server inputs private key, which is the thing used to verify any particular tokens that come out of this particular credential, as well as the presentation limit. And upon like running this presentation check, the server learns whether or not the token derived from this particular credential is valid or not. A Boolean, which is like what you would expect from privacy pass tokens in general. And importantly, the client gets an updated credential. So they can later then, if it needs to do another presentation from that credential, rederive a new token and spend it again, up to the rate limit. So it can, if the rate limit is 100, the client can do this 100 times without ever interacting with the issuer again, producing 100 tokens before it is effectively expired, or it has like saturated the credential, however you want to call it. Okay, so that's pretty much it. Like technically, there's some like more complicated stuff that happens under the hood. The CFRG draft sort of lays out the cryptography that's involved here, but from a functional perspective, ARC is fairly simple. It is, if we go back to that sort of diagram that Michele had on the screen, where you had privately verifiable and publicly verifiable credentials in multi-show versus one show. This is a privately verifiable multi-show scheme that complements the BBS work that is a publicly verifiable multi-show scheme that Watson helpfully put together in his PrivacyPass BBS spec. You can produce multiple tokens from a credential, and it has rate limiting built in, addressing both of the problems, allowing us to basically deprecate and replace this draft that we did adopt and decide to work on in this working group, thankfully. So that is it. Curious to see what people think. If there's any questions, we'd like to advocate this for adoption in particular because the problem of rate limiting was something this group already deemed was necessary and important. And this is a much more elegant solution, we think. But again, we understand that depending on where the group wants to go with anonymous credentials in general, or how it wants to cut the scope of anonymous credentials, we could either do that here or elsewhere. Don't feel super strongly, but this is a very obvious replacement to the more complicated thing. Raphael.
Yeah, as I said the other day in the CFRG meeting, I think this is interesting because as the initiator of the badge token draft, that was a problem I really cared about, and so the whole idea back then was to sort of amortize the cost for privately verifiable tokens. This goes much further, therefore it's more interesting. And I'm curious to see, how does it compare to badge tokens? Is there like a sweet spot where maybe badge tokens are still more efficient for low numbers of issuance? If there's a higher initial cost here, how available are implementations of the ARC primitive, stuff like that.
Yeah, good questions.
Only practical considerations. Otherwise, I'm in favor of adoption.
Our plan is to hopefully have some sort of performance evaluation to determine, as I said, where the sweet spot is, what the inflection point looks like, where ARC perhaps outperforms batch tokens. It's also worth noting that there's a bit of a functional difference as well, whereas like the batch token variant, you're like fetching a bag of tokens for one particular context, where the credential, because like the contexts are sort of defined at presentation time, or like basically when a token challenge comes in, you can sort of dynamically change the batch, if that makes sense, in real time. So for example, if I have a credential and a rate limit, if I'm in origin and I want to ask for a token that is rate limited to like 100 or something like that, in the normal case, I can do so with a token challenge. And let's say I get like under attack, whatever that means, I can shift my rate limit down to like 10. And that doesn't force the client to go through like a reissuance phase. The client just like takes its existing credential, plugs in the new rate limit, and starts producing tokens from that. So it's a little bit more flexible in terms of the policies you can express, which was important for some deployments. But yeah, anyways, we will do that comparison. As to availability of implementations, there's a reference implementation. I hope more implementations become available. Of course, our implementation is not available because that's how we operate, but maybe that'll change. Yeah, David.
David Skenazy. I had a clarification question, and you actually answered most of it already. So that means that you need to, from the server that controls the rate limit, have a message to the client anytime that's changed to make the rate limit kind of visible to the client,
Exactly.
right? Whereas before, it could be kind of secret sauce on the server.
Yeah.
Is that right? Cool. Okay. That's a limitation that for our use cases is kind of a problem, but I still think this is useful work because there are cases where that's not a problem. So thanks.
The making the rate limit like known to the client is a problem, you say?
Yes, because like you might not want to disclose that you're under attack, or
I see.
the rate limit could be per client, and you can't do that anymore necessarily with something like. Or if you do it like this, the client can detect it. Whereas if like your rate limit is based on the client, but it's all magic sauce hidden in the server, you don't need to tell the client that that's happening.
That's a good point. Tom, did you want to?
We could get into the details later, but one thing as I've been playing with this and how it maps in, that's not necessarily super obvious is that there is a limit, and it's not really a rate limit. It's a limit of presentations per presentation context. And so the presentation context that's being used is still up to the challenger, and that the kind of the content of that isn't necessarily known. So like a number limit, but you don't know the time over which that context is going to be used. So just having a limit, like the limit could be 10, but that just means you get 10 per any particular challenge context, and you don't know when those are going to change or anything else about it. So it's actually a little bit more flexible and malleable, and there's a slightly less information the client would know.
But to David's point, like the client still learns like what the rate limit is. It has to in order to like. Yeah. But that's enough. Like if it goes from like 1 million to like 10, like it's a pretty good signal. Like something's different.
But
Awesome,
I think we need to. Thank you.
Yeah. Thanks.
All right. Did you want me to?
It's not working. Slides. There we go. And we'll do.
You want me to give you?
Should let me do it.
Yeah, if you ask for it, you should get it.
It is not giving me the controller thing. Do you want to just
Let me see if. Oh, great. So where's the? All right, I'll just advance for you.
That's fine. All right, welcome. I should have asked the question at the end of ARC, which is like, does it support metadata? Because like, I'm the metadata guy today. All right, we're gonna talk about metadata. I think the context here is I just want to give
an overview of expiration extension. We've talked about this at multiple IETFs, but I've never really gone into the details because it's always like, and we have expiration. So we'll talk about that. Auth scheme extensions and public metadata issuance, you've seen a lot of. I just want to give an overview of those two because we're bringing, I believe we've already called auth scheme extensions for WGLC, and then we're going to bring public metadata issuance. Maybe I'm flipping that, but so those are both further along. Expiration extension, not adopted yet. Next slide, please. So next slide again. Thank you. First, we'll look at the world without expiration extension, which is like how a lot of PrivacyPass deployments work today. Without an expiration extension, you are waiting for keys to rotate in order to effectively expire an issued token. This only applies in a non-interactive context, meaning I'm going to get a token issued and doesn't have a nonce bound to it. So I can kind of hold on to that token for a period of time. I think a good example of this might actually be anonymous credentials, where we've issued a particular credential and we're saying that's valid until the signing key that credential was issued for is rotated out of use. So if we wanted to speed up expiry, well, the only thing we could do is change our key rotation schedule, which, like, if you're familiar with operating some of these systems, sometimes that's really easy and sometimes it's really hard. It depends how good your clients are at checking in and making sure that those keys are being rotated effectively. Next slide. So with expiration extensions, we get to scope down the size, or you can scope up, I don't know. But we get to be more flexible in the size of the groups that we are expiring. So in this particular example, I made the expiration times a lot shorter than what the key rotation time was allowing for. And this can be very convenient, especially when you want to make more dynamic changes to your key rotation times. In one example deployment that we use for the Google Pixel VPN, for example, our key rotation time is 10 days with a 3-day key overlap between keys, but we want to expire tokens significantly faster than that. And we use expiry to be able to adjust that. This can also be useful if you feel like you need to make an immediate change because of an issue with your system. You can simply roll out a slightly different token, slightly different expiration time. In practice, this is implemented with a very simple extension. It's a struct. This is, if you go look at the draft, this is pretty much the content of the draft. Is like, this is the struct. These are the two things you have. You have a timestamp precision field, which says like, hey, I want to round this timestamp to an hour or a day or whatever you want to set there. And then you have a timestamp field that says, this is the expiry time to be rounded to that precision. The purpose of the precision is to make sure that you have relatively large groups of clients all falling into the same expiry bucket. Otherwise, if you were putting expiry exactly, when an issuer received the piece of metadata to sign, for example, you may uniquely identify a client. And in the draft, we go into this in some detail where we try to say, expiry should be rounded to a particular amount that is correct for your particular deployment. Next slide. So this draft, the expiry draft, was requested to be at least considered for adoption into the working group as part of the larger metadata package that we've been discussing. We use it in Chrome IP protection along with a few other products. And the call for adoption on this one is open. Let's discuss this one and then we'll move on to the other metadata drafts. So, Martin.
Yeah, just a quick question. If this, you said you had a minimum size for the time period that you would allow, is that right? But these seems like absolute timestamps.
So there isn't a minimum that's set in the draft. Right. I think what you do in practice is you set precision and you expect the timestamp to be rounded to that particular precision. So you could say my precision is a day and you expect that rounding. Your clients have to agree on how that rounding is implemented.
Right. So I'm just a little concerned that one of the things that we've sort of got with the key rollovers is that having multiple keys active allows you to segregate your population of clients into smaller anonymity sets. Yeah. This effectively gives you the ability to get around the sort of limitations on key rotation that we have and target even smaller populations by sort of slicing them in by time. And particularly problematic, I think, here is that people who have clock skew who will stand out because their tokens will be valid.
So the clock skew should not. Okay, I see.
They will
believe
attempt to
their
use a thing
tokens- they
outside
believe
of the
them, they're valid.
window in which it's valid. They're thinking that it's valid, and you can know that it's valid because it's validated, but you'll also know that it's from this particular time window, and they will stand out as a result.
I think we may be able to address this concern by essentially taking the same constraints that we put into key rotation and bringing it into as recommendations for clients and verifiers and issuers in this draft as well. Maybe we haven't done a good enough job of that yet, but I think we can.
I'd just be concerned that you could use this to more effectively operationalize the segregation of populations based on timestamps. Obviously, there are other metadata that we're going to discuss that have the same property, but
right.
Yeah.
Well, yeah, other forms of metadata actually, like I think this is one of the most difficult from an identification perspective because it's less fixed. Some of the other forms that we're using are just a string, for example. I think we should definitely discuss that one more and try to address it effectively. I do think it's possible with the setup that we have here. I think a lot of these identification attacks really depend on the size of your population. And if you have an enormous population, you can make this work. And that's kind of the math that we've tried to do with our products. All right, let's head to the next slide. So now we will talk about the auth scheme extensions draft. This is the first of two of the sort of drafts that we need to make public metadata work. Next slide. So auth scheme extensions is a essentially adds, how do I want to explain this? We want clients to be able to present a particular extension to verifiers. So for example, their expiration extension. In order to do that, we need to modify the, in this case, the token challenge request and the subsequent request that heads from a client to an origin to enable these extensions to be put in there. The original version of this draft really just focused on the second part, which is like, what are the extensions that you're presenting to the issuer? And then what are the extensions that you're presenting to the verifier? The new updates, since we got the feedback on this, was we should also add the ability for clients to negotiate particular extensions. So they're going to say, you know, I support extensions XYZ, and the origins will say, I need you to support these particular extensions. So that new information and capability has been added into this draft as well. The way that we did that was relatively simple. Essentially, during the token challenge phase, we allow origins to specify saying, I am going to expect particular extensions to be present. And that's this extension set field. They can also fill in entire extensions. So if they want to say, you know, not only do I expect these particular extensions to be present, but I think this is probably what you want to set in here. A good example would be like those simple extensions that I mentioned where they have like string. This is what we use this for in practice. And then subsequently those can be presented. So this is pretty much the content of this draft. You'll see we now, you know, have the specifications laid out for all of these fields. The value of the extensions is not defined in this draft. That would be left for things like expiration extension or whatever other extensions folks want to create. Next slide. Just reviewing the feedback that we did get, we wanted to add extension negotiation. We now did add that capability. And we wanted to have an example extension that we would put into these fields, and we now have that draft in expiration extension. So that was the main feedback. Hopefully we have successfully addressed that. With that, you know, we think it's probably ready for a WGLC on this draft. We would definitely like to see more feedback on the draft. That would be really useful. Any comments on this one before we move to the next? Crickets. Cool. Public metadata issuance, this is the final one. Next slide. So public metadata issuance looks at a slightly different piece of this puzzle. So before we were looking at what happens when the interaction between the client and the origin, and that allowed us to specify the extensions there. Now we're looking at how does the client get these extensions signed before they bring them back to the origin? So it's this extended token request, extended token response, the finalization step, and then the subsequent request and verify steps that are modified to support issuance with public metadata. So I've presented these before at IETF. I won't go into too much detail in them, but high level concept is we really just needed to take the existing token request and token response and create new room for metadata to be passed in along with them. And we also needed to make sure that the crypto constructs supported metadata. And we have those standardized with the partially blind RSA, which is now adopted into the CFRG, as well as the PRPRFs. So we have ways to do this both with privately verifiable tokens and publicly verifiable tokens. Next slide. If I remember correctly, that's a typo because this is already up for WGLC, but we do need feedback on this one as well. And that's kind of the main one here is I don't think we've had a lot of feedback on this particular draft. Am I remembering that incorrectly, or is it auth scheme that's up? Is it like the things I should have prepared?
I think it's auth scheme.
Okay, so this one needs to go up, but like they kind of make sense as a package. We either want to do both or do none.
Right.
I think is the correct way to look at these. So that's my last slide on these topics. Does anybody have any feedback on metadata in general? We have 3 minutes to discuss. Cool. All right. Thank you.
All right. What's your next?
I think we're gonna do a tester issue. I'm back. Can't get rid of me that easily. Thank you for pulling this up. Should I ask to share slides again?
Well, it doesn't like give me the. Yeah, you can try that, but I need to get rid of these slides. Oops, I hit the wrong thing. Do it again. There we go. Do you have the, did you try to share them again?
I'll ask again.
Thank you. Now you should have, and you should have control.
Oh, wow. Yes.
If it shares it, actually. There we go.
All right. This is a separate topic. This is what I would consider like spec minutia. We're going to go over the tester issuer interface. If you remember in Chris's slides and some of my slides, there was like, and in one of our RFCs, there's this concept of a split attester issuer where the attester is responsible for verifying things like the client integrity or, it's a client from a particular identity system. And the issuer is responsible for actually signing the particular token. This split attester issuer model allows us to achieve certain privacy guarantees. And it's deployed in certain circumstances. When you're operating in the split attester issuer model, we never actually specify the interface between the attester and the issuer. So if you're building one of these, as I have, and you have two different attesters come to you and ask for two different things, I don't have a great way to work out these problems because there is no spec. So this spec tries to define these. The interface is really simple. It looks really similar to the existing interface that is defined, which is the token request and token response going into an attester. Here, we also need the token request, token response to go into the issuer. If it were this simple, I would say like we don't need a spec here. The issue I have is when we go to make changes. For example, in a batched issuance mode, that's when things get much more complicated and you start wanting to do a bunch of custom stuff that are defined between the attester and the issuer. So I think defining this interface is useful if we plan on continuing to use batched for some time. If we're saying, oh, we're all going to move to rate limited credentials batches in the past, then we shouldn't do this. But I don't know that that's necessarily going to be the case. As with most things, you end up operating the old system and potentially working on the new system for quite some time. And so I do think having a spec where we can work out these types of details in addition to incorporating a lot of the batch details would be really useful. And that is why I brought this up as a potential draft. The draft itself is extremely simple. I encourage everybody to take a look, and feedback on it would be greatly appreciated. So really the questions here are, this particular interface in PrivacyPass is not defined. We just talk about split attester issuer and we don't really specify it. Should we? You can see in the draft, it's not complicated. So I don't think it's a question of, are we adding a ton of complexity into the working group? It's more of a question of like, is this something that we want to work on? It definitely falls within the working group. And then if we are going to standardize this, what parts should the draft focus on? Right now, it's really just focused on the request and response. There's probably more that we can do around recommending how the issuer verifies requests from the attester. For example, I think in practice, everybody's using MTLS, but this is like something that probably could be standardized as well. So, and then I think an additional useful aspect of this is being able to specify what happens when we start to make more complex changes, like incorporate anonymous credentials or batched issuance. And with that, I would like to take any questions on this draft. Finally got some feedback.
Yeah, I didn't have any strong feeling either way here, but maybe one way to decide on whether this should be standardized or not is to determine if there are different parties implementing, the attester part and the issuer part, and whether we need interrupt between the two, or if it's always happening within the same organization, and then we don't care about interrupt, and thus standardization.
Can I request that a party implementing an attester comes up?
It's already in the queue. I do not implement the attester though. I don't do server code. Tommy, Polly, Apple. So yeah, I mean, I think this is useful for when you have the split case, and I think the split case is kind of definitionally interesting when it is between different parties. And so we have many cases right now where we have different parties being the issuer and we're an attester. But those cases are often like it's very customized, right? Like you're sharing some client cert, and like it's a very I've seen this happen now several times, and it's been proprietary, and like the issuer is like, I want it like this, and then things get customized in ways. So I guess I'd like to see something written down for just simplicity's sake, so that we don't reinvent the wheel many times. But I think the key bit is like what is like the right base way to communicate it with the right extensibility features that people want, and like how to extend this, because there are going to be things that people want to add, because these are going to be, if they're not in the same entity or corporation to begin with, then it's still a very it can be a very special relationship where there's information that wants to be shared. So like I've seen the batch stuff be handled with protobuf encoding, and I've seen it with JSON. Like there's just like all these different encodings and different ways to like add this like one other random key that needs to be passed. I could see it being like a slight convenience for those cases to say, yeah, standardize. But until you have like a more open ecosystem where you're just going to like be like randomly popping these onto an attester, there's not like a burning need for it. So I think I would support it. I think we'd want to run it by people who are already implementing these things, but also like really focus the draft on like, here are the ways to extend it. And if you need to handle batch different, like here are properties I want to say about the whole batch, or properties about any one entry in the batch, making that really clear. Like here's where you plug in your custom field, that would be useful.
So it sounds like there is some interest in it. So from an IETF procedure perspective, I guess the question is now, should this just be guidance or should it be a normative document?
Yeah. I mean, in my opinion, it should be, I wouldn't phrase it as guidance, because I think there are a lot of protocol specifics to get right. To Tommy's point, I maybe to make that decision, we would need a little more feedback from the folks implementing, both data testers and the issuers. Like, I know I could say on the issuer side, there's a lot of protocol specifics, I think, to get right when you do it. Like, it should be simple in theory, but and with this, I'm hoping we can cut down a lot of the customization and also some of the privacy foot guns there. It's like, yeah, don't share identifiers. Cool. You think that would be obvious? I think that's really important for us to be able to specify. But I think it would also be really useful to get more feedback from the testers on this as well.
So potentially we could go either way then, like with guidance, if we don't think that the specifying the protocol would still be useful to kind of have those privacy considerations. Okay. All right.
All right. Thank you all. And by the way, Thibaut is a co-author on this draft. I don't think he's in person today. So please follow up on the list with questions on all this stuff. Thank you.
All righty. Let's see, next we have reverse flow privacy pass. Whoops. You should be getting a control to Vault.
Yes, I just got control. Thanks. Also, during this session, because I was taking notes, if someone would be able to take notes, like during that session, happy to resume right after. That would be like good for like future readers that would get the notes properly. Okay. Well, can you hear me properly?
Yes.
Yes. Okay. Perfect. Great. So this presentation is about PrivacyPass reverse flow. I'm not sure if the name is correct, but we'll see throughout the presentation if people will come with a better name. So I'm Thibaut, working at Cloudflare. And yeah, let's go and dive into the detail. So I have slides which are very similar to Chris, I think. So this is PrivacyPass architecture, which we all know and love. You have an origin. When a client goes to the origin, it may be challenged. If it's challenged, it goes to an attester, perform like back and forth with it to ensure some property, such as device validity, like humanness, whatsoever. Once the attester has deemed the client to be worthy of passing the attestation, they go to the issuer, send like with a token request, send back the token response. The client finalizes the token and sends the request plus a token. And as we've seen as well with Chris, there are a couple of limitations with this existing flow, which like kind of hinder some like real world deployment. And in this case, if we discuss like rate limiting, if a client is misbehaving, how can I rate limit more? And like by that, I mean, there's like fixed rate limit that I want every client to be able to have like 100 requests per day or like a certain time window. But there might be also cases where I would like to give client only like a limited number of requests if like they're sending on like SQL injection or something. And that's not something with the unlinkability of PrivacyPass, which like I'm able to do. If I'm an origin and I just so happen to have more resources, because I don't know, it's like night and I would like people to send more requests during the night, how can I still allow like clients to contact me? Because I don't know, I don't control like the issuer or the attester, etc. And so this is unlinkable. How can I still allow it? As an attester, I'm providing like some trust on like when I issue like allow client to get token. If I don't know what they would do with it, should I know? I don't know, but like maybe like if they're misbehaving, that's something I should be able to like participate in. And once again, as an origin, how do I limit the requests that are going to the attester? I do think that's like something which is very well addressed, for instance, with the anonymous credential work that we've seen earlier today. But as of now, that's not something that exists. And therefore, we go with like the reverse flow. The reverse flow is basically the same as the architecture draft. It just we deploy it twice. So what happens is like the flow on the right is exactly the same. But when a client sends a request to the origin, it also sends a new token request to an issuer controlled by the origin. And so with this, if the origin deems like the client to be like honest, deems like has more resources or the problem before, it can like send a token request to like their own issuer and sends back the normal response to the client request plus a new token response signed by its own issuer. And so if we go over like the problem that we had before, if a client isn't behaving, how do I rate limit them? Well, I just don't issue new token. And so like if they don't have new token, they will have either to wait to go back to the attester. Maybe the attester is issuing tokens only every day, or they just don't come back for like a certain period of time. If an origin has more resources, how can you still allow client to like contact them? Well, I just issue new token. And like now instead of validating attester token, I will validate the origin token. As an attester, how can I know if a client isn't behaving? I just request origin token because I will know the origin would issue certain token if the request was valid. Same thing for the origin. How do I limit request to the attester? I can request my own token, and that works. The kind of like open question I have for this draft is definitely anonymous credential helps solve some of this problem, if not all, but like some of these problems are definitely solved by anonymous credential. Are people interested in this work? There's also some question around the mechanism on like how to pass token requests. Should it be HTTP header? Should it be like body wrapping? And should we actually focus specifically on this new part, which is how do we pass token request along with like a normal HTTP request? Or should we also like introduce this motivation for having like this double deployed architecture? Finally, one of the big questions is like the privacy guarantees. I think a lot of the new work done in PrivacyPass definitely like challenges some of the initial guarantee, which were like rather simple. How do we work around that and how do we define it? Questions?
Scott?
Thanks. One question I'd have about this work is what types of use cases do you see origins employing it for? Because it is a pretty complicated setup compared to what they're used to doing, just token verification. Now they have to maintain an issuer as well. So, where are they employing this and, where are they finding it valuable? I think that would be really useful also to compare it to the anonymous credentials work, where you still with anonymous credentials probably don't get the same level of feedback, where you can establish this feedback loop between origins here. But you are getting that rate limiting capability in still with a simpler origin implementation. Thanks.
Yes, I think definitely compared to the anonymous credential, there's like no new primitive. It's just compatible with like the existing architecture, existing token model, and etc. You can also combine public and private verification because the origin issuer could be something private and like benefit from like, I don't know, you have like a public attesters that like you're allowed to like bootstrap, for instance, one issuance of token and the origin can issue like a bunch more token like down the line. So it's more like a if we were to deploy something today that like minimizes the changes in like the cryptography layer, this is what what we would do.
Tommy Polly Apple. So thank you for bringing this. I think first the whole flow, I'd want to think about it in a lot of more detail to work out the whether I think we should do this or not. One thing I wanted to point out, I think you're aware of this case. There's another scenario where the origin can be an issuer. Also, is with like the concept of like a refund token, where you have the case where you've gotten tokens from somewhere else, the blind signature or say blind signature tokens, you are spending with the origin, then you decide, what you did was actually fairly lightweight. I don't want that to count against your rate limit. And if the client has issued a request for another token, it can be like, I'm going to issue you a new token that's equivalent to the token you already had, and you can kind of use it in the future. Do you see that? This kind of reminds me of that. Like, do you see these being related? Would it make sense to kind of specify some of these cases together where the origins are taking these like reverse roles, and maybe there are different use cases in different architectures where you have that reverse role? Maybe that token's going all the way back to the other attester side, or maybe it's just coming back to itself later. What do you think?
Yes. No, definitely that's a use case. I think like I had in mind when like building that, and there's a couple of like application for this flow. That's why I say like it's part of the architecture. It's just deploying it twice. The thing is when you deploy it twice is who are like the parties and like how do they identify? Should like when the client gets a token back from the origin, will it spend that token against that origin, or is it meant to be spent against the attester? How does that work? And that's why it could be useful to have like more detailed use cases. For the refund token, for instance, that's like what I mentioned with like dynamic rate limiting. You receive a token, you want the client to like keep contacting you, either because it's like middle of the night or because the request didn't cost you much or any reason. You issue them a token and like they keep on like contacting you back. And that flow just works for that. I think there's like a definition section at the beginning of the draft, which tries to like identify how we can have these roles and how that has implication in like how clients deal with it. In the end, it's really trying to make like to allow the possibility for clients to keep on spending token. If the client think that this flow doesn't work, well, when they receive a token from the origin, they don't use it, and that's it. So that's kind of like the modularity I think I want to introduce with this flow. Once again, it's an instantiation of the architecture, but like a specific way for the actors to interact. Should it be part of a new draft? That's one of the questions I have.
Jonathan Hoyland, Cloudflare. I really like this. And the use case I want to use this for is actually for bot authorization. So when you're talking about some kind of agentic AI kind of nonsense, use case, we might want to be able to have the bot say, oh yes, I'm acting for 10 different people or maybe one person, but they're all obeying their own rate limits. And we can like slash if they're doing bad stuff without like hurting other users. I really like this. I think we should do this.
Yeah, thank you. Maybe one more thing I think, like this is once again like very like policy related and like deployment related. The draft really needs a bit more work before we are able to do like all these properties.
Okay. So I think we'll need some more discussion on this, but it sounds promising. Next, we have privacy pass in TLS.
Okie dokie. Hello. So I'll be presenting this draft, which we put out. I co-wrote this very quickly with Scott after a conversation we had. So just want to see if we think this is an interesting direction to go. So we're going to put privacy passes in weird places. Okay. So normally, what we've been doing so far is using privacy pass as HTTP auth. Doesn't have to go there. There are other cases where people stuff it in other protocols, but RFC 9577 essentially just defines that this is a HTTP auth scheme. You get a challenge. You come back with a token, use some base 64 encoding, you have fun. This is generally the right place for a lot of applications to put the privacy pass token and the challenge. But there are other places. There's a draft that I think has been presented here that's not being worked on here, but is related for doing this in EAP. And that seems good. That seems fine. There are other protocols like SIP that are essentially HTTP for how they do authentication, but they're not HTTP. And so it's another way to put it. And there are other applications where you could put this in a protobuf of something if you want. These are usually something at the application level. However, there's also a use case, particularly around rate limiting, or like, is this a legitimate device, where you have a TLS terminator that's potentially well in front of the HTTP processing servers that are doing a lot of rate limiting, or particularly based on IPs. And when you have cases where IPs are going to be shared between more devices due to privacy proxies, or even due to really, really large NATs of carrier networks, you can be negatively impacted. So these TLS terminators can be blocking or degrading traffic before it reaches the servers that would otherwise be able to handle authentication like PrivacyPass. So this document essentially says we're going to use any token type that comes up, but we're going to stuff the challenge with alongside a cookie challenge in a hello retry request. And then when you come back with your cookie, if you have to, because you've gotten this challenge to say, hey, you need to prove you're real before you come back with your TLS handshake, you stuff the token in encrypted client hello. And this is essentially just a way to put the tokens in a TLS handshake there. And so this allows you to get that out of the way, and hopefully this TLS terminator is not penalizing you before you go into whatever the backend actually is. So this is designed to be just like the HTTP auth scheme. It doesn't really care what token type you use. In general, these types we're talking about of ARC or BBS would be the right things you want to do here. You probably do not want to be going back to some other server and issuing stuff in real time. If you're able to just generate a presentation locally on the device, that is a much better property. And when we were drawing this up, it was like, okay, you put this kind of along with the cookie. The cookie is essentially the redemption context. So this prevents the token reuse, replay problems, and you essentially just bind that to the cookie value. You send an encrypted client hello so that people aren't able to just see it and replay it trivially. So is this interesting? I mean, I'd be curious to hear, like how gross is this by putting in the handshake? Is this something that would be appropriate to talk about here? Is this something more that needs to go to TLS and coordinate with people here? I imagine, like the folks here have the context about how PrivacyPass is normally used and more of the motivations. Okay, questions? Martin, you were making some good faces over there. So,
yeah, I was making faces. The whole thing where it requires hello retry request leads me to ask some questions. Like,
if there's a better way,
yeah, we can probably work on that. I think most of the problems here are TLS shaped problems.
Yeah,
and so the TLS working group is probably in some ways better because of those things like how to fit it into hello retry request and how it interacts with ECH and all of that. I don't like the idea that you have unbound cookies in public client hellos, but I think it would be fine if you'd seen a challenge on that connection to have them in the clear, because they're otherwise useless and don't contain any identifiable information anyway.
Correct.
So there's things like that to work through, but generally okay with people going elsewhere. Now Joe's going to probably look at just stop listening for a moment.
Do you
Joe.
know about any
Going
people who
outside of
work in
TLS to
TLS?
do
I don't know
work in
anything about
TLS,
that.
but unfortunately, almost every time someone comes to do something with TLS, it's the TLS integration that's the hard part.
Yes.
And the TLS working group really needs to be the place that sort of thing happens. I'm also a little skeptical about the sort of use case here, and wonder whether it does need to be at this layer. That I kind of got where you're coming from, but a lot of the scenarios that I'm thinking about still end up with having some other interaction that precedes the TLS connection establishment, and so
That
maybe
precedes it.
precedes it. Yes.
Okay.
But maybe I'm.
Yeah. I don't know, Scott.
We can
if
work on some of them.
You want to? Yeah, I guess you're in line later.
This is
too,
the IP
so
protection cases that you're concerned. No.
I don't know how much you want to talk.
No, I mean actually different cases. If you imagine you have like a big global load balancer that's doing terminations, so like a cloud's load balancer or your Cloudflare or something, it's exactly those cases because that load balancer also tends to be very far or can be very far from the application server in terms of latency. And so for these cases, it's like kind of frustrating when you look at the flame graph of latency and you're like, my load balancer was over here. Now I'm spending 90 milliseconds to get to the place I was going, and I could have completed the privacy pass handshake to figure that out. And on top of that, we're potentially shedding connections that we didn't have to if we had the token ahead of time.
And so, like, essentially today, we do see problems where when you're using privacy proxies for going to certain large servers, you have to extremely carefully curate exactly how many connections you are allowing to be made from one IP. Otherwise, you will get blocked or get hit by crazy delays or captcha walls that destroy the user experience. And it's not a problem that the people doing the HTTP servers can solve. That the reality of where these blocks are put in are up here.
And it's not just privacy proxies, as you said before. CGNATs alone
Yes.
do this sometimes.
Yes. So it is partly a property of how these things have been built and their assumption around seeing IPs, but it is a reality that is challenging. And this may be a way out of that or a way to improve that situation incrementally. Raphael.
Yeah, just some more questions from my side. So, having implemented Privacy Pass in a system essentially at the HTTP level, you maybe don't want to do that at the very end. You want to have it as some sort of middleware that speaks HTTP and can sort of filter that out before it hits the final server. So if we would still use HTTP inside TLS here, you could also move that closer to the TLS terminator rather than having it at the very end after the 90 milliseconds. Just thinking out loud. But so what strikes me as potentially difficult here is that TLS terminators are typically not stateful, and now all of a sudden they have to be because they're round trips. They have to also remember the nonces for the double spending and stuff like that. So I have no idea how realistic that actually is.
So I think that, and we can get into the details like separately in the review, but the goal of the spelling here of having it be with a cookie and hello retry request is that you remain stateless, that you are generating unique redemption contexts per challenge. And it's essentially just like, here's just like this one-time thing, just prove you can get a token.
Okay, sorry, I missed that part then.
Yeah. Ben.
Hey, so mostly +1 to what Raphael said. I think there's, it seems like the problem here to pop up a level of abstraction is about privacy pass deployment in large scale HTTP gateways. That's the motivating use case where you have basically the CDN use case, CDN architecture. It's like, what if we want to do privacy pass at the CDN instead of at the origin?
I mean, not. I think it's a particular instantiations of that. I think we see cases of CDNs where they do it just fine with it being at HTTP. I think these. I don't want to speak for all of the deployments. I don't know, Scott, if you have other things, but like it's not just just that, because I agree that there are better ways. It's just like you could just put the HTTP up at the front, like, but that's not always the case, and I don't think we're going to make some large server deployments do that.
Yeah, I think also depends on the value of the token. Like you may also want to have privacy pass inside HTTP in addition to using this. So it really depends on what you're attempting to use that token for. In this particular use case, it may just be for like the DOS mitigation style rate limiting, where we're going to see the most value, and there may be like subsequent underlying use cases that that would still use privacy pass for other purposes at the HTTP layer.
So if we are in a situation where we can't have multiple privacy pass contexts in a single HTTP request, then maybe that's a problem of its own.
I don't think that's the motivation. Like, I think there could be other ways to handle that.
Yeah, because in general, the TLS terminator here also has access to the HTTP plaintext. So anything that you're doing in the client hello, if you're speaking HTTP over TLS, that TLS terminator is about to decrypt and then could apply its rate limiting at the request level, looking at the request plaintext and do privacy pass there.
I think it may be partially. Oh, finish your point, please.
My point is that I would like to see a little bit more discussion of the motivation before jumping to a particular technical solution, because it just seems like there might be an HTTP layer solution to this, or some other, or a variety, really a very wide variety of different possible technical solutions. And I think basically rate limiting of connections from hyperscale proxies is a really interesting problem that we should think about as a problem and not just as a solution.
I mean, I think it's fair. I think we should discuss the use cases more. The doc can possibly on the list as well. The thing I've been thinking about most here is separation of concerns, where you may be like not the hyperscale proxy, but the hyperscale cloud, or just a cloud that terminates lots of connections, and you have many different customers all with different workloads, and you may not be able to effectively introspect into the HTTP to like do stuff for each of those workloads in a custom way. But if you knew just that, for particular workloads, you have privacy pass configured at the TLS layer, maybe you could offer this as more of like a configurable option. So that makes it fit better with those separations of concerns of like what those layers are doing with these tokens.
Okay, Thibault.
Yes, Thibault Cloudflare, as has been mentioned before, I do think this is like very useful for like moving some privacy pass verification and redemption earlier in the stack to like avoid some like latency performance that would be induced by like only having that at the HTTP layer. I had some comment on the mailing list, but yeah, that's it. Thanks. I'm in support.
Awesome. Thank you.
All right.
So, yeah, I think it sounds like we want to, do some updates, add what we can about motivation use case details, and share it with TLS group as well.
Yeah, I mean,
we can find if we know any of the chairs. There.
Yeah, no, yeah, they're not agreeable to these sorts of things. Next up, yeah. Do you want me to give you? No. Token binding. And then I think.
Okay. Hello, everyone. I'm Frank. Liangxia from Huawei. So my colleague Wigor has some other issues. So this time I present for him. So actually, this is a 0.0 new draft. We are talking about a new proposal, a new extension to the current privacy pass token. We call it the token binding, which is mainly used to protect this token cannot be stolen by some attacker and to illegally access protected resource. Okay, so next page. Okay, so like the OAuth token, the token, if it's stolen by some attacker, of course it can be used by him to impersonate the legal user and to access the protected resource server. So, so as a below figure shows that the attacker can get the token and invalid access the resource. So, so with this kind of problem, we know that currently in the OAuth, for their token, they have the token binding mechanism, or we call it the proof of possession. Okay, here there are some different options, like the token binding for OAuth 2, or the DPoP or MTLS. They all can implement this kind of token binding by binding the client long-term public key to this token. But okay, this is a good mechanism for the OAuth token, but for privacy pass token, it is not applicable because if we use this one key, one long public key, it will break the privacy pass the unlinkability features, because this one public key can link to all of the issued privacy pass tokens. So this is not applicable for privacy pass. So in our draft, we propose that use a one-time public key to do this token binding. So with this kind of mechanism, of course, we can protect the OAuth stolen with token binding. And we also don't break the privacy pass unlinkability features. Okay, how to produce this one-time public key pair? Actually, here we don't introduce any new crypto primitives. We use a small non-interactive zero knowledge proof. And with this kind of algorithms, and so we can generate the public key pair from a seed, and with very fast speed to generate the one-time public key for every privacy pass tokens. So okay, that's that's a basic idea for this privacy pass token binding. And optionally, we can also do the trend binding with this privacy token with below on the layer TLS channel with the existing TLS trend binding or HPKE trend binding mechanism to enhance the total security of the connection. Okay, this page is some details. I don't want to go into details, but the basic idea is that during the two phases of the privacy pass token process, during the issuing process and during resumption process, we all need to incorporate the public key, one-time public key, in the whole process, and ensure the token for this client. With binding the public key. Then the client uses token binding the public key to access the resource. And the resource can validate whether the client really owns the corresponding private key. So to avoid the token stolen and the wrong using. That's this is the basic idea of this draft. So this is a new draft. So if you have any questions or comments, we are warmly welcome.
Jonathan Hoyden, Cloudflare. I'm a bit confused about your threat model. Could you go back a slide, please? So if the attacker can already steal from local storage, why can't they steal the one-time secret key, one-time private key?
That's a good question, yeah. I think that's maybe we can consider this from system security level. We can have some hardware part to protect this key to leakage.
Well, then
Yeah.
you just stick the token in the hardware security module, right? So-
Yeah, you can't.
I'm not very familiar with it, but I think this problem also happened in the in the OAuth POP problem, the airspace. So since OAuth needs this kind of authorization, why not privacy pass do not? This is my concern right now.
So in OAuth, it's okay to stick. You can say, oh, we have high security storage for long-term keys and low security storage for everything else. But in this, it's high security storage for short-term stuff. So if you're going to have if you're going to put ephemeral stuff in high security storage, just put the tokens in high security storage.
One point I want to emphasize here is that because when I talk about the hardware storage, because we use SNOR zero knowledge proof, it has a benefit that it has only need a seed, and use this seed, it can dynamically calculate the public one-time public key pair on time. So we only need to store this seed with high. Yeah, that's one thing I want to emphasize here.
Yeah, I do want to point out HSMs on, even like our phones usually have like pretty limited amount of storage available. So like it may not be possible to store token batches. In the Chrome IP protection case, the token batch can get quite large, and it would be large enough where I wouldn't want to put it into an HSM necessarily. There may be power concerns with that as well. So I do see the use case of having like high and low separation here. Maybe there's a possibility. In PrivacyPass, we can operate in a couple different modes. One of them is more of like this interactive mode where the origin produces a nonce and that gets signed over. You bring that back during verification. Is that also a defense for the same attack here, where you're basically scoping the amount of time attacker has to be able to effectively steal and reuse that token to the duration of the nonce?
Maybe I can talk with you offline. Sorry, I'm not very familiar. But just according to last question, I think I just realized this attack scenario is not about the attacker will attack attack the clients because if the attacker stole the token on the link, it's also attack scenario. Yeah. Okay.
So just going back to interactive versus non-interactive, I do wonder if this work may still be very useful for defending the non-interactive use cases where we don't use that nonce, and those are deployed because token theft is a concern for those use cases. So,
yes.
Thank you.
Thank you.
Okay. Aaron?
Yeah. Hi, Aaron Parecki. I'm mostly in the OAuth working group here, so I wanted to clarify some of the stuff around some of what I just heard. Please read Depop and the OAuth best security best current practice RFC 9700, as well as the browser-based apps document, which is in the publication queue now. There's a very, very thorough analysis done around token theft in browsers, done in the browser-based apps draft, and yep, and it talks a lot about the differences in the threats based on what you're putting where and why. So it seems like that's entirely all relevant here too. So I would draw from that as much as you can.
This is helpful. We will take
but there's also a huge difference between generating something and storing it versus the browser APIs that let you generate a public key in the browser or a private key in the browser that then can't be extracted from the JavaScript, and those give you very different possibilities of what you can do with that as well. So it's what I was hearing was a lot of, well, why can't you just like put this in the browser If you can put it in the browser and it can be stolen, then why can't the private key be stolen? It doesn't exactly work that way. There's some interesting things you can do, but this is all captured already in the browser apps BCP.
Okay. Yeah. Thank you for this information. Yeah.
So it seems like we should try to coordinate on this.
Just briefly, this general class of thing is quite interesting in the sense that it gives you additional layers of defense for these things, particularly on the in-flight case. This differs from OAuth in that in a lot of cases, an OAuth token is good for a long time and many operations, and a lot of them are high value. These tokens tend to be for low value transactions, and each token is only good for one use. So the exposure is very different, and it may be that you know, in addition to all the comments that others have made here, the additional layers of protection aren't necessarily justified in a lot of the use cases. Now, it may be that there are some cases where you're using PrivacyPass to authorize something that's fairly significant, in which case you would want to do those things. And I think it's probably beholden to us to go and find those examples to justify doing work along these lines. As much as it's interesting, I really like the idea of being able to have some sort of key in long-term storage and then some sort of KDF that you use to generate a private key that then guarantees that your proof never leaves that machine. But that's a lot of work, and I think we need pretty strong justification for it. And I'm not quite seeing it just yet.
Yes, thank you.
So the spot that I see this potentially being useful, because Martin, I think you're correct. Usually you're not talking about very high impact for any one individual operation that's being protected with PrivacyPass. So you'd have to be both protecting, it's most likely an expensive operation, not necessarily a sensitive operation. And an attacker likely needs to be able to scale that attack into some sort of denial of service or something that's going to be very expensive for the operator to handle all of those requests. That's why I think, again, non-interactive is very interesting and where you'd want to apply this, both because I think interactive is already well protected from nonces. But in the non-interactive case, generally an attacker, if they're harvesting across many devices, can build up a large cache of tokens. And if you're protecting something expensive and they come back all at once and say, I would like to do all of these operations at once, it may not be good for the operator. So that's where I see this most likely being useful. And we should follow up and try to enumerate maybe more specific use cases or examples of where we might want to employ something like this.
Jonathan Hoyland, Cloudflare. Just a maybe slightly orthogonal thought. There were some really interesting discussions earlier in the week about whether you could create a new token type in OAuth and shove a PrivacyPass token in there. And so maybe we could actually tie all of this together and like make PrivacyPass fit into OAuth in some kind of pretty bow magic.
All right, I think we're at the end of the session, I believe. And so thank you all. And we'll, follow up on the list on these various things and see you perhaps in an interim. And if not, we'll see you in Madrid. Right. The other two we want to bring into so I think we had been yeah. So yeah, no, thank you. All right, what did I do?